of size 4 cross 4, implementation of Q-learning with Python. The frozen lake involves crossing a frozen lake from start S to goal Z. This is the start state and this is goal state. Here, the agent can take any direction. Either agent can move towards right side or towards downside. If agent is at this point, agent can move in the upward direction or he can move in the left side direction. In the state space, total 16 spaces are there because it is a 4 cross 4. Total 16 spaces are there. This you will consider as S0 and the goal we can consider the state as S15. In the entire states, S0 is the start state, S15 is goal state, and these are the holes where if the agent falls in this holes region, then it will end the episode. Apart from that, the left out states are the frozen lake states. So this is frozen state, frozen state, frozen state, frozen. This was a frozen state, frozen state, frozen state, frozen state, frozen state, and frozen state. We have a different action spaces. The agent take at any point one element vector where the agent can move in four directions, either towards a left side or move towards a right side. Agent can move in upward direction or agent can move in the downward direction. So these are the action spaces we have. 0 we use for left, 1 for down, 2 for right direction, 3 for up direction. The observation is space is nothing but what are the different spaces which can be possible whenever the agent is taking some action. So the number of possible observation is depends upon the size of the map. Let us consider if you consider a 4 cross 4 map, we are having a 16 possible observation. Coming to rewards, if the agent reaches the goal, we are going to get the reward as +1. If the agent is reaching to a hole that is H or frozen space that is F, agent will receive a reward of 0. For creating environment in the gym library, use the command env is equivalent to gym.make and we have to pass few arguments. The first argument is what is the environment we are choosing. Here we are choosing Frozen Lake version 1. The next parameter is DESC. The next one is map name. Next one is slippery. The last we can pass as render mode. Out of all these options, the first, the environment is compulsion. The remaining things are optional. We can omit these arguments also. The DESC argument, it is used to specify the custom map for frozen lake. If the frozen lake we want as start frozen, 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 hole, frozen, hole, frozen, 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 hole, hole, frozen, frozen, goal. So this is the map we have to assign for DESC. If you want to change this map, whatever the user choice for each and every row, we can pass here. If I want to create one more hole instead of here, I want to place it. So in that case, I can write here the second element as frozen. This also I'll change to frozen, frozen, whole. Whereas in third row, I'll write as frozen followed by whole, frozen, whole. Then I'll get this is whole space will be added here and this whole space will be deleted. Suppose if you want to generate a random, a pattern or map, then we have to import a generate a random map from gym dot environments dot toy underscore text dot frozen underscore link. Then we have to give the statement as for env is equivalent to gym dot make frozen link DASC. Then we will write generate a random map. Here we can specify the size. Either it is maybe 4 or it can be 8. The next argument we have is map name. This map name it is used to preload maps for 4 cross 4. The maps are start frozen, frozen, frozen till whole frozen, frozen, goal. If it is 8 cross 8, this is the preloaded maps. The next argument we have is render mode. This render mode we have two ways. One is we can use as human. The second one we can use the render mode as RGB array. If the human mode is used, then it opens a window to display the live scene for each and every episode, how the agent is moving that we can visualize. If we use RGB array, then the scene will be considered as an RGB array. We can estimate the values we can return at the output side. Is slippery. For is slippery, whether we can pass true or false. If true, then the agent move in intended direction with a probability of 1 by 3, else move in the either perpendicular direction with an equal probability of 1 by 3 in both directions. Let us consider if action is considered as left and if slippery is true. Our intended action is left because the slippery is selected. The agent may move in towards left, up and downward direction. So as per our action, the agent has to move in left side. This is left side intended action, but the agent will move either in the upward direction or downward direction, which are perpendicular to the intended direction. So as three actions are there, we will get the probability of each and every action is equivalent to 1 by 3. If slippery is not there, then whatever the intended action is there, for that we are going to give the probability as 1. For Q learning, the updation for QSA values as QSA is equivalent to QSA plus alpha times of R plus gamma times of the maximum Q value for a particular state and action minus Q state and action. Here, alpha is learning rate, gamma is a discount factor, R is a reward. So here the updation will be takes place with respect to these actions. In the Q table, as per frozen lake environment, we have four actions, namely left, down, right, and up action. For each and every state, as we are considering a 4 cross 4 frozen environment, we are having the states from S0 to S15. Total 16 states are there. For each and every state, whatever the Q value is there, that will be updated for each and every action in this table. Whenever we are intended to find out what is the Q values or Q maximum values, they are going to evaluate from this particular Q table. For implementation of this Q learning mechanism on the frozen table, we are using the Python code. In the Python code, few parameters are required. In the program, we are going to consider the number of episodes Total number of the episodes are 10,000 we are going to be consider. The learning rate is 0.2. In each and every episode, the maximum episodes we are taking as 100. So what is this maximum episode for maximum steps in episode is when we start from the start, our goal is to reach the state goal. So the agent move in any direction. Maximum we are allowing is 100 steps. So there are two possible cases. The agent may reach goal within the 100 steps, then the episode will be ends. Otherwise, even though after taking 100 steps, if the agent is not reaching to the goal, then episode will be terminated. So these are the two cases you can consider. One is reaching the goal within the what are the steps the user is selecting. Here I have selected 100 steps. Within the 100 steps, if the goal is not reached, then that particular episode will be terminated. Next, the discount factor is 0.9. Epsilon decay rate and epsilon maximum, epsilon minimum. These are used for exploitation and exploration of the episodes. So initially depend upon we are going to select the epsilon value within the uniform distribution from 0 to 1. If it is greater than epsilon, then we will take the maximum value from the Q table. Else we are going to sample the Q table for a QSC. So initially we will select the epsilon with, let us consider some value 1. This decay rate will be added for updating the epsilon, which is a function of, we can write as epsilon minimum, comma, epsilon maximum, comma, a decay rate and episode. So there are multiple ways for updating the epsilon. So what are the epsilon which are updating? Based upon that, the Q values will be selected accordingly from the Q table, which are we are having for the 16 states with 4 action. So the size of Q table here we are going to be consider is as it is consist of 16 states, it will consist of 16 rows, and as we have 4 actions, so we are going to have 4 columns in the Q table. Now we'll move to implementation using Python. The first statement, we will write import numpy as np. Next, we'll import the gym library using import gym. For generation of a random number, we will use import random. Next, we will create environment that env is equivalent to gym.make, and here we are using the frozen lake hyphen v1. Next, render mode is equivalent to, first I'll show with respect to RGB underscore array. Later we will move to human. Here we can also add slippery. So first we will write the slippery as false. Then we will examine the output with respect to slippery is equivalent to true. So I am taking only with respect to frozen lake, render mode is RGB array. Then action space. First, for displaying the action space, we need to see how many actions are there. So we will take this one as action space underscore size is equivalent to in the environment, whichever we have selected, action space underscore. Yeah. If you want to see the number of actions which is possible in this environment, then you can print the number of actions action underscore space underscore size. Similarly, if you want to see how many state space are there, that we can write as state space size is equivalent to environment observation space dot n. Now we go for display the number of states. State space size. Now just and run this. So the number of actions are 4 in number. The number of states are 16. So this is only for finding out how many actions are there and how many spaces we have. So either we can include these statements or we can delete these statements. Now we will create a Q table. So Q table is equivalent to the size of Q table is number of actions decides the number of columns as well as number of rows will be depends upon the number of states. So Q table will write as Q table is equivalent to np dot zeros. We are initializing with zeros with state space size comma actions space size. So these two arguments we are removed. Observation space not 10. Action space size is env dot action space n. So now if you see the Q table, we go for print Q table. It will create a Q table with 16 rows and 4 columns with all the values are initialized as 0. Now we will define the parameters. So the parameters are a number of episodes. So the number of episodes we are taking as 10,000. Then the learning rate alpha we are taking as 0.2. Maximum episodes maximum steps in episodes we will take as 100. The discount factor gamma is equivalent to 0.9. Initial epsilon we will initialize with 1. Decay rate you can take as 0.01. Then the minimum value of epsilon and maximum value of epsilon. So epsilon maximum will take as 1 and epsilon minimum value will assign as 0.01. So these are the user parameters. Next, here we are going to estimate the rewards. So we'll initialize with the empty list. We can write epsilon values as empty list. Next, success rate we can define with an empty list. Now we go for iterating for each and every episode. So we'll write for episode in range of episodes. So here we are selected 10,000 episodes. So the for loop will be iterated for 10,000. Initially, we will take the state as for resetting. So that will write as env dot reset. So whenever you execute env dot reset, it is going to provide two parameters. So we require only state. So that will be there at a 0th index. So initial step we will assign as 0. Then whether it is reached to the goal with a variable will take as done. We will assign as false. For each and every episode, we will take the reward as initialized with 0. Next, we go for iterating for each and every step in the episode. For step in range, as we are assigned the maximum steps as max underscore steps. So we go for iterating till that portion. Our for loop will be iterated for each and every step until maximum steps is equivalent to 100. In each and every step, first we have to take the action. So the action will be taken based upon the epsilon value. So for that we'll write if random dot uniform distribution within the range of 0 to 1 is greater than epsilon, then we will assign the action as action will be considered from the Q table, which action it has to take. So the action will be calculated with the arg maximum np dot arg maximum of Q table for a selected state out of all the actions. So we'll select all the column entries for a particular row that is will be defined as state all the columns because each and every column will be given for one action. Out of four action, whichever it is having the maximum Q value, that action will be considered. Else, we go for a random selection of the action space. So that we can write as action is equivalent to environment dot action underscore space dot sample. So any random action will be selected. So once the action is selected, then we are going to be update the Q table. For updation of the Q table, we have to know what is the next state and reward. So for that, next state, comma, what is the reward and whether it is reached to the goal or not, and termination, comma, info. So these are the two parameters which we are not required for each and every step. So env dot step For every state and action, it is going to provide five outputs. One is next state, reward, whether done. Done is nothing but whether we have reached the goal or not. Then it is going to provide two more parameters, that is terminated. The next one is info. So as we don't require those, we are removing it. So whenever you take a particular action, what is the step it is going to take, that will be given by this. Next, we will find out, we want to update the Q maximum value or maximum Q value, because in the Q learning updation of Q, for that we require the maximum Q value. We will take maximum Q is assigned with np dot maximum of the Q table, for which Q table we have to consider is whatever the new state which it is generated, that is nothing but the next state for all the actions we have to consider. Future will be updated last. So Q table for a state comma action plus learning rate times of reward plus gamma times of maximum Q minus Q table of state comma action. So once Q table is updated, then we will add episode reward. So episode reward plus equivalent to reward. So updated the episode reward. Then we will change the state with the next state. Suppose if agent is reached to the goal, then that will be intimated on done. That is done will be true. So here we'll check whether the agent is at the terminal state or not. How we can check is if done is equivalent to true, as the episode is terminated or episode is done, we'll break the loop. Otherwise, we go for updating the epsilon. So epsilon will be updated with the value of maximum of epsilon minimum, comma epsilon maximum minus whatever the decay rate which you have selected, decay rate times of episode. So once this loop is done for each and every step, once this loop is done, so for each and every episode, this loop will be iterated for maximum 100 times. If the agent moves to goal state, then the loop will be terminated. So here we are going to be update the rewards. So rewards will be updated as rewards dot append, as we are declared as a empty list. So for that we are going to be updated the rewards with the episode reward. Similarly, success will be updated if episode reward is greater than 0, else success will be updated with 0. So that we can write as if episode reward is greater than 0, we know that only for goal we are given the episode as episode reward is equivalent to, sorry, reward is equivalent to +1, for remaining cases 0. So when our episode reward is greater than 0, then we will write the success is done. So we will update the success. What is the variable we are considered? Success. So into this list, we will append 1. Else, we will append whether that particular episode is success or not. So if it is eps- reward is greater than 0, we will take that one as a success. Otherwise, it is not success. So once all the episodes are done, now we go for printing the mean reward. So mean reward we can estimate as the sum of rewards divided by total number of episodes. Because here the rewards are updated for all the episodes. Now we want to find out what is the mean reward. Actually, more specific, we can write as mean reward per episode. It is sum of the rewards divided by total number of episodes. If you want to see the Q table, we go for printing the Q table. I'll give the label for this. So this is the program for running for all the episodes. Now we want to see the output. Then we can run for few episodes. Again, we will start with for episode. Let us consider I want to check for only 5 episodes. Before that, we want to reset the environment. We can reset the environment with environment reset. Once the environment is reset, then we will iterate the loop for 5 times. Here we go for fetching the state. So how we will fetch the state is env dot reset. Once it is reset at 0th index, it is having state. So that will take us. So I want to check how many steps it is taking for episode, whether it is reached to the goal or also we can check. So steps will take us 0. Then done is equivalent to false. Then we'll define what is the episode number. For this episode number, as the episode is starting with 0, we will write this one as episode +1, indicating this is the first episode. For instead of 0, we'll start with 1. env.render, it is for displaying the output. Here we have selected in the make, we have selected this one as RGB array. Then we will see the human case also. Environment render. Next, we go for iterating for the steps. For step in range of steps, that is maximum steps, which we have dictated as 100. We will fetch action. So the action is equivalent to np dot maximum, which is arg maximum we have to take because I want to pick which action is having highest Q value. So np dot arg maximum, because training is done. Only we have to evaluate. So from the Q table for a particular state and all the actions. So once action is defined, then we will update the next state for each and every action. What is the next state it is going to give? What is the reward? What is the status of agent, whether it is reached the goal or not, terminated, comma, info, which is equivalent to env dot step for a particular action. So once we estimated these values, then you will write if done. If the agent is reached to the goal, if for loop is done, then we want to print or we want to assign the state with the next state. So let us consider here when or how many steps it is required for completion of the goal. That if you want to display here, we can write print number of steps it is considered in a particular episode. That will define what is the step number. So once our loop is everything is done, we can go for closing the environment by env close. So once environment close is done, we go for running the program. So here we got the mean reward is equivalent to 0.4 for all the episodes. It is only the mean by dividing 10,000 episodes. And this is the Q table for each and every state. What is the reward for a particular state? This is for S0 state for action 1, action 2, action 3, and action 4. Like this, we are going to have total 16 rows. Wherever 0 is there, it indicates it is for whole or goal. So whenever we are reaching to whole, the reward is equivalent to 0. So for these states, we'll have the Q table with the value of 0. So now, if you observe in the episode 1, it is taking 6 steps. For episode 2, 5 steps. For episode 3, 19 steps. For episode 4, 49 steps. For episode 5, 4 steps it is taking for reaching to the goal. Now, if I want to see the movement of the agent, so here you can go for changing the render mode as human. So whenever you change the render mode is equivalent to human, then it is going to display the visualization of the agent moving. So like this, we can display the frozen lake also. Next here, we can also define the slippery. So for slippery, we will write is slippery is equivalent to. Now we'll see with respect to the slippery case also. Now I'll show with respect to render mode as RGB array. So here the mean reward we are getting as 0.4205, and these are the Q tables. So what are the Q values which are obtaining, and the mean values will be depends upon this random number which are it is generating, as well as the slippery. If you write the slippery as false, so here we are getting the mean reward is equivalent to 0.9338, but here it is 0.4205. So what are the Q values and mean reward? It will depends upon, as we are considered, this is a random number generation. So always it will depend upon what is the random number it is generated. So this is the program for environment using Q learning mechanism. Thank you all.